Welcome to SP Smart's NEET Direct program. Today we shall discuss the problems from NCERT book from the chapter of bulk matter, part 2nd. So let's start from example 10.10. The terminal velocity of a copper ball of radius 2 millimeter, it is 2 millimeter, which makes us 2 10 power minus 3 meters. It's falling through the tank of oil at 20 degree with speed. Okay, this is the terminal velocity 6.5 centimeter per second. I change this into meters. So many meter per second. This is the terminal velocity. Compute the viscosity of the oil. Well, eta you have to find out. Density of the oil is given. This is given 1.5 10 power 3 kg per meter cube. Density of copper is given 8.9 10 power 3 kilogram per meter cube. So, as you can see, both the density of oil as well as copper and everything is given, and temperature 20 degrees C. So that means temperature constant. So we are not supposed to consider temperature at all because it's not a variable. It is constant throughout the experiment, right? Well, as you know, there is a formula for terminal velocity 2 by 9 gr square rho minus sigma by eta. Start putting the values. Terminal velocity is 6.5 10 power minus 2. So 6.5 10 power minus 2. 2 by 9 into what you have here?
Hello.
You have 2 by 9. G is 9.8. Square of the radius. Square of the radius. As you can see, the radius is 2 millimeter. It's given here. 2 millimeter. And this 2, this is millimeter square. Then you have sigma and rho. It is 8.9 10 power 3 minus 1.5 10 power 3. 1.5 10 power 3 divided by eta. That is something we have to find out. Alright. Okay, on simplification, eta comes out to be 9.9 10 power minus 1 Pascal second, which means it's 0.99 Pascal second. That is the answer for this problem. In other words, the viscosity of this oil is 0.99 Pascal second, right? Okay, now let's move on to the next example. It's 10.6. A car lift compressed air exerts a force F1 on a small piston. Well, this question is about hydraulic lift. So better I draw a simple diagram, then I will explain what is written in this numerical. Well, this is diagram of a hydraulic lift. As per the question, force F1 is exerted on the small piston. So this is force F1 here. It has a radius of 5 centimeter. So radius is 5 centimeter, which I write as 5 10 power minus 2 meters. The pressure is transmitted to the second piston, a radius of 15 centimeter. So this radius is 15 centimeter. I change this to meters now. The mass of the car to be lifted is 1350 kilogram. So this mass is 1350 kg. You have to calculate F1. This is F1. What is the pressure necessary to accomplish this task? Take G as 9.8 meter per second square. It's written over there. What's the pressure required? So I have written all the data in front of the figure. Now we are able to do this problem very effectively and easily. If I consider the pressure at piston P, it should be same as at piston 2. When I say piston P1, it's here. Piston P2 is this. So the two pressures are equal. Why? As per Pascal's law. Pressure is force by area. And this force and this area. Small area has been denoted by small a, large area is by capital A. Okay. Now let's simplify it. F1 divided by pi r1 square, and it is F2 pi r2 square. As per this data, I've written small r and capital R. So would it be fine or better if I write this way? This is r square. This load is m into g. This is load of the car, and the radius is this. F1 therefore is mg r squared by r squared. 1350, I have written the value of m, the mass of the car. G is 9.8. Small radius, as you can see here, is 5 10 power minus 2. Large is 15 10 power minus 2. So it's 5 10 power minus 2. And this is 15 10 power minus 2. And we have to take the whole square. Alright, simplify it further. Certain things cancel out, this cancels out, this cancels out. 5 3s are 15, so we have 135 into 98 because I've removed the decimal with this 0, and now you have 1.9 because 3 that is squared becomes 1 by 9, right? On simplification it becomes 1470 Newton. So force on the smaller piston is 1470 Newton. Right. So one part is over. Now we have to know the pressure exerted. And as far as the pressure exerted is concerned, the pressure that is required here, P2, which is the pressure on the larger piston. It is force upon area. Force means mg, the weight of the car, upon area. Area is pi r capital square. This is 1350, the weight of the car as mentioned here, and into g, which is 9.8, pi is 3.14, into radius is 15 10 power minus 2 whole square. Now simplify it. Now turns out that it is 18.7 into 10 power 4. Rest I have adjusted all the zeros except this, so it is 10 power 4 positive. And this is the pressure. If you want to simplify it further, it becomes now 1.87 10 power 5, and that means roughly 1.9 10 power 5 Pascal. This is the pressure needed on the right side. This is a pressure due to the car. Now what's the pressure required to push the car, to adjust the car, to lift the car? That will be pressure P1. Pressure P1, it is force F1 by area. F1 force we just calculated a couple of minutes ago, 1470. So it's 1470 upon pi r square. It is 1470, 3.14. Radius is how much? Radius is 5 10 power minus 2. So it's 5 10 power minus 2 whole square. Simplified further, it turns out to be 1.8 into 10 power 5 Pascal. Let's compare. It's 1.87 here also. So it's 1.87 is roughly 1.9 10 power 5 Pascal. This is a pressure needed on the left hand side piston. In short, this numerical establishes the truthfulness of Pascal's law, because pressure on the larger piston is 1.9 10 power 5 and pressure on the smaller piston is also 1.9 10 power 5. That is, the two pressures are equal in accordance with Pascal's law, which says fluids exert equal pressure at all points in all directions. So in this way we have finished NEET direct programs NCERT problem from the chapter of bulk matter part 2nd. All these problems have been discussed, and that's all for today. God bless you all.